Hello everyone, welcome back to my channel. Hope all of you are doing great. Today in this video we're going to learn Cisco ACI packet forwarding. And yes, this is very first part of this packet flow series, and believe me, if you watch the entire series there will be no doubt in terms of packet forwarding and packet flow. Alright, so let's get started. This is a very basic leaf spine topology I have explained over here, and as I always show you with two layer, right, or two section, you can say first is the logical layer where your tenant VRF VD all exist, which I have explained in this video, which might reflect in the I button. Through that you can check out my video where I have explained what are the logical component and how to configure that in detail, right? You can check out that video also. And now next part is that the physical part, right? So what is the physical part or access layer rather, where your actual device gets connected or your physical device gets connected to your logical ACI network infra. And that I have explained in another video, which might reflect over here in this I button. You can check out that video where I have explained these endpoints, how it will be connect and how it configure, right? So that you can get more knowledge on that, right? And then check this video also where I have explained the forwarding, right? Now in this topology you can see there is two spine switch, three leaf switches, right? And they talk to each other within this infra VRF or overlay VRF, you can say. And here within this VRF there is a tape address, each switch having the VTAP interface, where one IP address is also configured, which helps to establish the VXLAN tunnel, and using this tunnel they do forward and they talk to each other, right? But what about the spine? They don't use the VTAP for the forwarding. They do use for the forwarding Unicast tape, right? Unicast tape address they do use for the forwarding, right? And mostly traffic no need to travel to spine all of the time. Most of the time, the end of the day, our data center network communicate in the east-west traffic flow manner, right? So each leaf switch talks to other or nearby or remote leaf switch, right? So this is how it's get communicate over here. But thing is that this is very high level, but we'll understand in deep level, right? That's what we are here. So we'll understand with scenario basis, right? How the scenario basis that I'm going to explain you. With 4 scenario, I will try to explain each and every part. First scenario is that source leaf knows the destination on the same leaf, right? So source leaf, so the source leaf knows where is the destination, and that is on the same leaf. This is the scenario 1, right? And what about the scenario 2? Scenario 2 is source leaf knows the destinations on the another leaf. He knows the destination, but that is on the different leaf, right? And that is presented on that leaf only, right? This is the second scenario could be. And the third scenario could be the source leaf doesn't know the destination, right? He don't know the where is the destination. So what they will do, he will forward the packet to spine. That would be the third scenario, right? And what about the fourth scenario? Fourth scenario, the source leaf doesn't know the same. You can see the leaf doesn't know the where the destination. So what he do? He will flood, right? That could be the another scenario. With this four scenario, you will understand each and every part. All right. Now I'm going to explain our today's video focus is on first scenario, right? So what about the first scenario? First scenario, source leaf knows the destination on the same leaf, right? In that case, how the traffic get flow or how the traffic get forward, right? So let's understand that. Let's go to the scenario 1. Here I will explain the scenario 1 definitely. And before that, the forwarding, understanding the forwarding, we have to understand a couple of things. That first is how these leaf switches, Cisco ACI leaf switches, maintain the table, right? We know in legacy network or in traditional network, they do maintain a table, some kind of table to forward this traffic, right? It could be routing table, it could be layer 2 table, right? So that we will understand over here, right? So let's understand first. So if this how this switch maintain the table, let's understand here. I have explained, but with comparing with the traditional network, right? This is your traditional network table, this is your Cisco ACI network table. How do they maintain? This is the purpose, right? So here L3 routing forwarding, for the L3 routing forwarding, in traditional network we do use rev table, right? Sorry, it's my bad. A rev table, and that we do maintain /32 and non/32 IP addresses to maintain the routing table or rev table, rather rev table we would say. And yes, for the Cisco ACI we do maintain the same thing. The rev table we do also maintain, right? Here the same thing, but here we maintain the non/32 or non for the IPv6 non/28 IP addresses, right? And for the L3 L2 forwarding, we in traditional network we do maintain MAC table, right? And ARP table also. But here the beauty part of this ACI infrastructure table architecture, that is they combine this MAC table and the ARP table in a single table, that over here we call as a endpoint table. In endpoint table we do maintain MAC address as well as IP address of the endpoints, right? Here we will store some kind of store, you can say, and maintain the MAC or IP address together in a single table, right? And yes, if you say the relationship for the ARP table, in traditional network we do maintain one ARP table definitely, and here also we do maintain the ARP table. But here in ACI infrastructure we do maintain for a specific purpose. Let me explain the specific purpose. For the L3 out sorry, excuse me. Yeah, here just this is your leaf switch, right? And that your leaf switch is connected to a router, right? And that router is connected with your service provider or ISP internet, right? This is your internet cloud. So for this L3 out, it's difficult to maintain all this internet route and information in a endpoint table. It's a useless of use the resources, right? So that's what over here we do use ARP table for this L3 out. For this specific purpose we do maintain to connect the legacy or traditional network to communicate with other worlds. We do maintain the ARP table, right? So this is how we do maintain the tables, right? Hope it's clear for you, right? So let's go back. Now here we understand how they do maintain the table. Now we'll understand the endpoints. They do maintain the endpoints table, but what is the endpoint, right? Let's understand about this part first. So yes, this is the logical part definitely, but under that only we do connect the endpoints. So that's what I have explained over here. Now what is the endpoint? Endpoint is nothing but combinations of MAC address and IP addresses, right? And anything can be connected with MAC address and IP address. It could be physical and virtual, and that will be treated as endpoints, right? And here in against this MAC address there could be multiple IP addresses, right? But single MAC addresses, that will be treated as a endpoints, right? Now I will explain how many type of endpoints we do use in ACI infra. First, that physical local endpoint. Please bear with me few times for the drawing. Yeah. So this is, you can say, physically connected, right? Physically connected local endpoint, right? And second thing is endpoint type is, you can say, virtual local endpoint, right? So what about the virtual local endpoint? That is, if this left switch port gets connected to a virtual switch, right, like Cisco AVS, in that case it will be treated as virtual local endpoints, right? And here I want to clarify one thing. If I connect any virtual switches like AVS, In that case, here also we do maintain one VTF, and that VTF will establish another tunnel to reach over here, right, for the AVS perspective, virtual switch perspective, right. We do maintain this thing also, right. So hope it is clear. Let me take the eraser, otherwise it will be untidy. Please bear with me a few times. Let me erase all the stuffs. All right, it's erased. Let me take the pen. Yeah, so two type of endpoint we understood. Now part 3. Oh my god, part 3 is little bigger because the endpoint is also bigger. So how the type 3 endpoints, that is the remote endpoints. Remote endpoints. So what is the remote endpoint? Any endpoints connected to different leaf switch, right, that will be treated as a remote endpoint, separate switch that will be treated as a remote endpoint, right. So this endpoint is remote to this leaf switch. That's what we call this endpoint for this leaf switch as a remote endpoint, right. Hope it is clear. And for this leaf, this endpoint will be treated as a remote endpoint, right. Hope it is clear. Makes sense, right? Let me erase again, otherwise the board will be untidy. Yeah. Now third part is the fourth type of the on pair endpoint. So what is the on pair endpoint? That I am going to explain to you. If just suppose, hope you work with the Cisco Nexus environment where you have configured the VPC, right? Any server is connected with the VPC facility or VPC feature, where if any server gets connected in a single switch, that we will treat as a orphan port, right? Orphan port we do treat in earlier or legacy or traditional network in Nexus environment. So this orphan port will treat as a on pair endpoints because it's remote endpoints for this leaf switch and also for this leaf switch, right? For both of them it's an endpoint, but as these endpoints get learned via using this VPC configurations or VPC flow, in that case we'll understand as a on pair endpoints, right. Hope it is clear. And another type is the bounds, that I will explain in different. So for now you can understand this four type of endpoints you might face during any deployment or any ACI infrastructure, right. So hope it is clear. Yes, it is clear. Now we'll understand the forwarding, right. But before forwarding, we understand the how this switch understand the endpoints, how it's learn the endpoints, right. Then only we can understand the forwarding. So our objective is to understand the forwarding, how these devices communicate with this device. But before that, we have to understand how these endpoints get learned. Again, here is three way you can understand with three process this leaf switch understand the endpoints, right. So how the three processes: first, if any packet gets flow, any data traffic gets flow to this front panel ports, right, any front panel ports and with the MAC address, and that's get learned as a local endpoints. Why front panel? If any endpoint learn via this link, right, from the spine or from the other leaf links, in that case it will not be treated as endpoints, right, local endpoints, right. So always whenever any traffic hits to the front panel of any leaf switches, that will be treated as a local endpoint. So how it's get learned: first, one packet in any host which is connected to a leaf switch and that forward the packet with MAC address that's stored in a table, then that endpoint treat as a local endpoints. This is how it can learn the endpoints. Now what about the IP addresses? Now IP address, this leaf switch learns in two way, right? First is the L3 forwarding for the routing. If this host sends any packet via the data plane to travel, right, or for the routing, in that case it is read the source MAC address as the local IP, so local MAC address, and source IP address as a local IP addresses. This is how understand. Another part is the MAC address via the ARP table. Now how the ARP table gets learned, let me explain to you over here. Just think one ARP request get generated by this server, right, by this server, right. Now once this ARP request get forward to the leaf switch, then it's not like forward to other ports or like this way. What it does, it decapsulate, right? It see the source MAC addresses and the destination MAC address. Then it stored the source MAC address in his table and maintain as a source MAC address or local endpoint MAC address. Not only here, ACI is more clever and more intelligent than you think. What it does, it's de-encapsulate, or it's remove the header, and it knows the source IP and destination IP, right? Then it stored the IP address also. This is how it stored the IP as well as MAC address using your ARP flood, right, or ARP request. It doesn't flood this ARP request to anywhere else. It's learn, it encapsulate, it's open your payload, or you open your header. From there it's learn the IP address, right? This is very unique over here. And what it does, it store this information to a table that over here call is LST. What is LST? Local station table. Whatever the devices locally gets connected, that is called over here local station table, right, or endpoint table. So LST informations they do maintain. Once this server gets communicate to other server, right, this communication, this forwarding happen as like a traditional or legacy network happen as simple switch. If you connected two server or two laptop in a single L2 switch, and they how do communicate each other, the same thing happen over here also. But here what this ACI switch makes different, that they do maintain, they do learn IP address and MAC address, and they do maintain a table, that is the LST, right, update to a LST, local station table. And main part is that they learn all this MAC address and IP address via the data plane, right. So once these tables get ready, right, all your MAC addresses or endpoint IP address get mapped to a endpoint table. Now how do you check the endpoint table? That is most important question, right? Let me explain this part over here also. So what is how do you check? You have to log into the leaf switch. First scenario, you have to log into the leaf switch and you have to run one command, show endpoint table, right? So in this table you have to run show endpoint IP, then the IP address what you want to see. In place of the IP you can put the MAC address also, right, through which you can check. So once you put the command, you will see this kind of output. Let me explain over here. This is very important part, right? In this encap, it will mention your VLAN, from which VLAN you belongs to, right? And here it will show you IP as well as MAC address, right? IP as well as MAC address. It will hold these two things, right? And now MAC info and IP info, how did he learn? Locally. As I told you, if anything is connected to a leaf switch and that packets get forward to a front panel port, right, in that case it will be treated as a local endpoint, right? So here in if you've connected a virtual switch, in that case also it will show the local endpoint, but here you can see the interface is also showing for this server. This is the interface, right? And this is the local endpoint, and in place of, if you connected any virtual machine, in place of the interface it will show the tunnel interface. As I have told you, it will maintain the tunnel interface if you connected any virtual switch like AVS in place of server, right? So if it is on pair endpoint, then over here it will return like O, right? Then in that case we will understand this is the on pair table, and if it is remote, then it will return another R kind of thing, right? Hope it is clear. Now apart from this, you can see encap VLAN, and this is the VLAN. Now what is that? Why these two VLAN and different VLAN ID overlays? So this VLAN is not your encapsulation VLAN, as you are familiar. This is your platform independent VLAN, PID VLAN, right? Or PI VLAN. Yeah. So this is called as a PI VLAN, as this is encapsulation VLAN, right? Hope it is clear. So what is PI VLAN and how it's work, that I will explain in separate video, and definitely I will explain, because otherwise how do you understand? But yes, this is the PI VLAN and this is your encapsulation VLAN, what you know and what you frequently use, right? And how do you know the other endpoint details? You have to run the similar command, so endpoint and the IP address of the second endpoint, all right, and they will get a similar output where your encapsulation VLAN mentioned, PI VLAN will be mentioned, and your MAC and IP will be binding, right? This is your endpoint kind of table. And definitely, as it's a local endpoint, so it will return over here local endpoints, and definitely it's an interface 2, you can see, right? So over here also the interface 2 will definitely mention. So this is how you can check, right, the information of endpoint table or the information of the LST table. So LST table maintain or built in locally in the switch to manage or maintain the local informations, right? Local table, local endpoint informations, right? So this is called elastic. Please keep in mind, I will give you another example, another terminology I always call is elastic, right, in separate video. So LST is local station table, right? Okay, all right. So hope it is clear now. As I told you, you have to log in the lift switches. You have to run the command to understand all these endpoints, right? But apart from this, you have to see, or you can check over the GUI also. How do you check? There is the option. Let me show you. I'm not going to take you into the lab, but yes, I am showing you over the snap only, because it's not good to take you waste your time to go to the lab and show you all the stuff. This is the screenshot, you can say. So how we'll check? You just click on the tenant, right? Under the tenant, you have to select the EPG, right? And under EPG, you have to click on the operational, right? Under the operational, there is client endpoints. Yeah, there you have to click, and under that you will see the same thing, whatever you have seen just before that. The VLAN detail, the interface detail, all switch in the, here is the interface detail, right, and the IP detail and the MAC detail, right, and the endpoint detail. Hope it is clear. So this is how you can check through CLI as well as through GUI the endpoint table informations, right? All right, hope it is clear. Now the main part I always explain, that is all the stuffs, how this switch gets learned this MAC address over the data plane, how it's learned the IP addresses. This is the most important, how it's learned the IP addresses. That's only possible once you enable under this your bridge domain, under the L3 configuration, you have to enable the Unicast routing, right? Under this L3 configurations, you have to enable the L3 routing, right? L3 unicast routing. Then only it will be treated as L3, and then only it will learn the IP addresses or forward the L3 subnets, whatever you have created under the bridge domains to your endpoints. Otherwise, there is no way to push up the subnets, whatever you have configured in the bridge domain, and there is no other mechanism to learn this IP addresses using your header, right, on the data plane. So you always have to enable the unicast routing under the bridge domain. So let me explain more on that part. Let me erase. As I told you here, in my separate video I have explained what is bridge domain, and that might show you in I button. You can check out that also. So what is the bridge domain? Bridge domain, every time you might see any document or in my video, that bridge domain nothing but your broadcast domain. So what is broadcast domain? Like an earlier legacy network, in legacy traditional network, we broadcast domain means VLAN, right? VLAN. But here we use broadcast domain. Under the broadcast domain, multiple EPG endpoint group we do create, right, as we require. But thing is that if you broadcast anything, it will be broadcast enter your VLAN, right? But here EPG is not your VLAN, right? If anything broadcast happening in your bridge domain, that enter all the EPGs will learn this broadcast, right? So this is your broadcast domain, nothing but it's a broadcast domain. Let me erase few parts. All right. So again let me explain with scenario with comparing to legacy network. As you people are very familiar with legacy network, it's good to compare with always with the legacy network or traditional network. Like if it's a L3 switch, even I also explained earlier also, it's a L3 switch. If I don't configure any L3 interface SBI, in that case there will be no L3 communication happen, right? Your L3 IP address will not get broadcast or not get any communication happen, right? The same way over here, you have to enable the unicast routing, L3 routing, right? Then only your IP address will be pushed to your endpoints, and once your endpoints sends any traffic to your bridge domain or your leaf, it won't be able to read the IP addresses. So that's what you have to make enable the L3 in your bridge domain. All right, this is how you can understand. I don't know whether it makes sense or not for you, because I always prefer to compare with a legacy network so that you can understand, right? So it's a kind of you are enabling the L3 VLAN, then only it's understand your L3 packets, because L3 communication is happening, right? Hope it is clear. All right, so let me explain another part. Now what left, that is the most important part, that is the all the IP and MAC are learn over here via using data plane, right? And even IP also learn via the data plane. This is the most important part in the ACI infrastructure. You can disable that part, but it's not recommended. But thing is that yes, other than a legacy network, over here we learn the IP addresses using data plane. Any data packet forward to your leaf switch using that data traffic, we can learn the MAC address. So no need to go to the control plane another part. All right, hope it is clear. So yeah, so hope it's informative, hope it is clear for you. How do we maintain the LST, how do we one MAC address get learned? All right, hope it is clear, makes sense. All right, so for now it's done, and we have completed this first scenario, right? You can say this is the first scenario I have just completed, right? And now in next video I will cover up the second scenario, the most important part. I will make the video public if you have in the demand on that. The source leaf knows the destinations, and another leaf, there I will explain very in deep, and you will understand each and every part of how the traffic gets flow from one leaf to another leaf, right? So for now it's done. Thank you, thanks for your patience. Hope it makes sense. If you like this video, please like and share to others so that it make easier for everyone, right? Yeah, thanks for your time. Have a good day.